everyone. Come on in. It is noon, so we're going to go ahead and get started. Welcome to week 3, everyone. We're really pleased that you've been able to carve out some time and join us today. My name is Marian Champion, and I'm the Government and Public Affairs Manager at Mission Springs Water District. I'm joined today by representatives from the other 5 water districts here in the Valley, including Coachella Valley Water District, Coachella Water Authority, Desert Water Agency, Indio Water Authority, and Myoma Dunes Water Company. If you have not already done so, please type your name and your agency, if it's applicable, into the chat so that we can note your attendance. A little housekeeping before we move on. If you have any questions, please use the Q&A feature or the raised hand feature in the Zoom controls. We will have some time for Q&A after each presentation, and if we don't get around to your question, we will be reaching out after the sessions to make sure they get answered. During weeks 1 and 2, you heard about our water sources, including the Colorado River and the State Water Project, our regional planning efforts, along with an update on the California drought, climate change, and some of our water conservation efforts each of our districts are currently undertaking. Today, we are going to shift gears and talk about our water quality and some of our recycled water efforts here in the Valley. Our first speaker, let me go ahead and get my slides there. Our first speaker is Steve Bigley, who is the Director of Environmental Services for the Coachella Valley Water District. Steve has been with the agency for more than 34 years, handling water resources, water quality management, and regulatory compliance for the district. He has served on work groups and committees for the National Drinking Water Advisory Council, the U.S. Environmental Protection Agency, and the Water Research Foundation, evaluating drinking water issues. He currently chairs the Association of California Water Agencies Safe Drinking Water Committee. Steve, would you like to share your screen?
All right, can you see me and can you hear me?
Looks and sounds great. Thank you.
Great. All right. Thank you. I always enjoy being able to share water quality with the groups, and I like to do it in person, but we'll do it virtually. And let's start with the water cycle. You know, you probably remember this from your high school days, and it could just as easily be called the salt cycle, because what it is it represents water transforming from fresh water to salt water and back and forth. And that's important for what we're going to talk about. Anything that dissolves in water is considered a contaminant. And as we also learned in high school, water is that universal solvent. It's very reactive when it exists as H2O, which is actually quite difficult to find it in that pure state. It's constantly acting to dissolve things it comes in contact with. And it does that in the atmosphere as soon as it condenses. And it begins its path to become more and more stable by dissolving more and more things in the water. Typically, these are minerals, or what we call salts. And if you look here on the table I've provided, that's a measurement of salinity in parts per million. And you can see typically our fresh water and the sources that we use for drinking water, typically below 1,000 milligrams parts per million. And it goes up to the oceans, which is about 35,000 parts per million. And then there's those other water bodies that aren't connected to the ocean, like the Salton Sea, about twice the concentration of the ocean, and the Great Salt Lake, Dead Sea. So you can see these hypersaline water bodies can really concentrate the salts. I'm happy to report that our tap water is primarily H2O, 99.97%. That little sliver represents all of the things that's dissolved in H2O. And it's typically minerals, calcium, magnesium, sodium, potassium. But we hear a lot about that part, which represents about 1 10,000ths of 1% of the water, which is those things in the news like arsenic and lead and copper and those things. So we're going to talk a lot about those things. In order to ensure our water is safe, we have lots of tools. And from doing research like that we do in our own state certified laboratory, there's a photo there to the right. Lots of contaminant monitoring. How do we protect those sources that we use for drinking water? Of course, state and federal regulations are that key way of measuring and ensuring consumer confidence that we are providing safe water. We implement water treatment when necessary. We do surveys to ensure that the safety of the water and the water system exists. How we construct the water system also helps protect it and preserve safe water quality. Backflow prevention. How do we make sure that when we deliver that water, it doesn't return to our water system in a contaminated state? We do that with backflow devices like the one in the photo down at the bottom right. We work with our customers and ensure that we report all this data, and that's what you see on our websites, the annual water quality reports that show the results. So regulations, that's one of the primary ways we show compliance. And regulations are broken down into primary maximum contaminant levels, MCLs, you'll hear that term a lot, that are based on health concerns. They are enforceable. And then there's secondary MCLs that are based on aesthetics, like color or odor, that are non-enforceable. EPA develops regulations that are nationally implemented and enforced. Then the states can they can either adopt what EPA adopts straight across, or they can adopt even more stringent standards. And that chart there just shows after 1972, when the Safe Drinking Water Act was signed, we saw an increase in drinking water regulations. And in the late 1980s, that's about when I was hired, it was really related to the increase in drinking water regulations and the compliance activities that water agencies have to do. So this just shows, no surprise, California leads the country in having the most stringent drinking water standards. They have standards that no other state has. They have standards that the federal government doesn't have. And New York is not too far behind. I just provided some examples down at the bottom. The most recent standard that the state has adopted, 1,2,3 trichloropropane, was adopted a couple of years ago. And this is measured in nanograms per liter, which would be equivalent to parts per trillion. So it just shows how sensitive some of our instruments are now that are used for regulations. When EPA adopts regulations, they primarily look at, is there an adverse health effect for whatever contaminant they're looking at? Does it actually occur in drinking water at levels that might be a concern? And then, is it technically and economically feasible to reduce that contaminant to a level where there would be risk reduction or benefits? So they often use animal studies to take a look at the toxicity or the health effect of the contaminant. This is a typical dose response where you're looking on the x-axis as the substance dose increases. You may see an increased adverse response on the y-axis. First thing you'll see here is they all end up with 100% adverse effect. That's the number one rule in toxicology. The dose makes the poison. You've probably heard that. All contaminants, everything essential, is also damaging at a high enough dose. And we have three primary ways we look at these dose responses. The first one would be one for an essential nutrient. So you can see down here, if it's essential and you don't have it, you're going to have an adverse response. But then there's this place where you're in the sweet spot where you have no effects, you're meeting your essential requirement, but at some point it departs from that no effect level. And that's always the level that you are looking for regulation. And then it, of course, as the dose increases, the adverse effect increases. The ideal scenario is for a threshold dose response. This would be the typical dose response for a non-essential element, where you increase the dose to a level where you see a departure and you want to regulate as close to that level, but no need to regulate further down until that departure. But then you have the case where there's a lot of uncertainty. You don't have robust data sets. And you might know what happens up here, but you really don't know what happens in between. And the default way to approach that is a linear dose response, where there is no safe level. It's an assumption that there's no safe level. And often this is the method that's used for drinking water regulations because of limited data. So when EPA sets standards, they look at that occurrence out in the water systems. They look at whether or not we can reduce the risks with treatment technologies and what is the cost. And they do something called a health risk cost analysis to set that standard as close to the maximum benefit based on the economic feasibility. And they usually provide 3 to 5 years for compliance. So that's a very tried and true method. Now we're going to shift gears locally and look at how, what we have here in the Valley and an example of a state standard process. So here's a aerial of our Valley, about 50 miles. There's the Salton Sea off to the right. The windmills are over here in the pass area. And the first thing that stands out are these red lines, and those are the faults. So this is the San Andreas fault system. I put those on here because they're very important when we look at water quality. They can drive water quality. So to the north, we have a couple of water basins, the Mission Creek subbasin and the Desert Hot Springs subbasin, and then the very large Indio subbasin to the south of the fault. And contaminants can occur naturally. So this area down in the east Coachella Valley is below sea level. Salton Sea is about 230 feet below sea level. And in this area, we have ancient deposits where the seas have inundated the valley and receded over many, many times. So there's layers and layers of high salt water in the groundwater, but shallow. So we don't use this. It exceeds drinking water standards. We wouldn't use this for drinking, but it's something we have to look at. Fluoride and salinity is associated with geothermal upwelling associated with the faults. The Desert Hot Springs subbasin, the spas, the mineral spas, all related to the geology and the faulting system. Again, you wouldn't use this for drinking water, but it's still used now for hot mineral spas. Arsenic. So we have very pure water, but it's very deep. It's been there a long time. And the minerals can dissolve in minute levels, but can exceed drinking water standards. So we have that situation for arsenic. We have other naturally occurring sediments like chromium that occur in a larger area. And that's going to be the subject of further discussion in this. And then we have something like strontium that's not regulated, but it's something that we looked at recently, and we found it throughout the valley. And we don't know if that might be a future thing that we'll need to avoid or control. Again, naturally occurring in the groundwater. So let's take a look at the chromium. It really serves as a good example for the state process for drinking water regulations. Chromium is abundant. It's the 11th most abundant element in the Earth's crust. And it occurs in two oxidation states. Chromium-3, you typically find that in more solid forms. It can also be dissolved in water, and chromium-6. And it just has to do with the number of electrons, and it can move back and forth between them depending on the type of environment. If you're in a reducing environment, antioxidants, you'll have a chromium-3 version. If you're in an oxidizing environment, you'll have chromium-3. In groundwater, we find it not just in our area, but throughout the state, it primarily occurs as chromium-6. Chromium-3 is an essential nutrient. It's in your vitamins. We use it to produce insulin, regulate our metabolisms. So the sources, natural deposits. So those fault systems, again, very important. Where do you find the geology that has higher concentrations of naturally occurring chromium? Along the margins of faults. So we have a really big margin. It cuts right down the middle of the valley. So we have these natural minerals that have chromium. Off to the right there, I've got some examples. You've probably seen trails like that. That kind of green appearance, that is serpentine, the California state rock. And it's green because of chromium. Chromo, Latin, is colorful. In water, it's yellow. In rubies, it's red. In serpentine, it's green. And so very common element, and it dissolves in minute levels into the groundwater. We've known a lot about chromium-6 from an inhalation. A lot of occupational exposures were done early in the 70s for people working in chromium ore facilities. We knew it's not healthy to inhale, but when it enters our digestive system, it goes through our stomach, which is a great reducing environment. We're designed to reduce chromium-6 to chromium-3 because we need it. We need that chromium-3. So it was never a concern from ingestion until some rodent studies came up. So let's take a look. This is a summary of the most recent rodent study, and really the one that is the basis for the state moving forward with developing a drinking water standard. And what this shows is, this would be the show and tell part, those flasks that we would normally have in the class. It's impressive the amount of the contaminant that the rodents are exposed to. The lowest dose is 5,000 parts per billion. And you can see down there, it has a slight color to it. And it goes all the way up to 90,000 parts per billion. So it's actually surprising that they saw no increased mortality in the rodents, both rats and mice, that were used in these studies. But they did see an increased number of tumors that formed in the small intestine. The best case for looking at this was the male mice small intestine. That's the first organ leaving the stomach. And that, remember, that stomach is where the reduction of chromium-6 would occur. So you can see the yellow highlighted boxes show that there was a statistically significant increase in tumor formation. And that's what they look for in these animal studies to see if it's a carcinogen. Some scientists say, yes, this is a concern. Many scientists look at this data and say, yeah, it's kind of looking like there's a threshold below which there's no effect. You can see down here at the 10,000 level, we actually had a lower effect than at the 5,000 level. So you really didn't have any effect until you got up to that 30,000 part per billion level. Of course, you'd never see that in drinking water. So this is the basis for California's regulation. So I could easily have put the title Science versus Legislation. They had a 1968 rodent study. Unfortunately, the UC Blue Ribbon panel looked at it and said, well, the virus that was throughout the study actually causes the tumors that you found, so they had to throw that out. But it was the basis for a movie, and that movie was about chromium-6, and it was about industrial contamination, not naturally occurring. Although they didn't see any health effects in the town. They've done 3 epidemiology studies for the Hinckley, and there were no effects, but it did get a lot of attention, enough to where we all had to go out and do testing. And yes, we found chromium-6 in those drinking water sources, low levels, typically below 20 parts per billion. And you kind of see it throughout the state. Not surprising to see it along fault margins. And our legislators saw this, and the Ortiz bill in 2001 said, well, we need to regulate that chromium. And they gave us 3 years for the state to come up with the regulation. Unfortunately, there was no science to base it on. The rodent study was flawed. So they had to do a new rodent study. And that took time. And sure enough, you saw those results. They gave the rodents enough chromium to have an effect. And that was the basis for developing the regulation. Although they had 3 years to do it, and we were already almost at year 10. So they got sued. The state got sued. And as a result of the lawsuit, a court order ruled that the state needed to set the standard at 10 parts per billion, which they did in 2014. Unfortunately, they didn't provide any time to comply. So we joined with Senator Hueso, and in 2015, an urgency measure bill was passed to give us 5 years to install treatment and comply with the rule. Meanwhile, another lawsuit was going on. The Solano County taxpayers sued the state of California because the rule was not cost effective. It was not economically feasible to implement. And a court ruled in their favor and said, you know, the state didn't even do an economic feasibility analysis, and they threw out the rule, the first time ever in California. Now the state has come back to take another look at it, because the Ortiz bill requires that they do this. So they had a cost workshop in 2020. And for the first time, this time around, they're doing an environmental review. They've acknowledged that there are environmental effects when you go and treat water for chromium. You end up with waste products. You have facilities at communities that can be looked at as environmental impacts. And they've come out now with an administrative draft, and they use the same number, 10 parts per billion. That was about a year ago. And they got some comments. They had some mistakes in it, and they got comments that required some revisions. And they have now come out with their standardized regulatory impact assessment. They didn't do this the first time around. They actually acknowledged that there is a great enough financial impact to have to trigger this assessment. So they are teed up to come out with a draft rule this March, maybe next month, and then complete the rule by the end of the year. So quite a process that the state is using. Whether or not it's valued or appropriate, or the science justifies it, we have to comply. So we've done a lot of work on this. And why? Because we have the most number of wells or drinking water sources in the whole state that would have been impacted by this 10 part per billion standard. So the costs were very high for our community. We estimated it would double the cost of our drinking water in this for our water systems. So we did a lot of work on this, primarily because we treated a few wells down by the Salton Sea for naturally occurring arsenic using ion exchange. And ion exchange is one of the principal ways you can also treat chromium and reduce chromium-6 levels. Here shows our treatment plant, one of our treatment plants to the right. They're basically like giant water softeners, but switch the positive to negative ions. And you end up with a whole bunch of salt brine waste product, some of which becomes hazardous waste that requires disposal and high costs. So we were on track to move forward with that project when the state withdrew their standard, but we didn't stop looking for a better way. So we continued with our state certified laboratory doing treatment studies. There's an example to the right, ultimately landing on a better option. We did work on using a very well-known antioxidant or reductant, vitamin C. We did a lot of work on vitamin C. It works well for an in-home product. You can easily add 200 milligrams of powdered vitamin C to a gallon, and you'll immediately reduce the chromium-6 level in that gallon of water. But it wouldn't work out in our water system. But we did identify another common antioxidant that's already approved drinking water additive. It's used to protect pipes, and that's called stannous chloride. And we did lots of testing in our lab, a much better reducing agent than iron and vitamin C. And we ultimately developed a full-scale demonstration treating an entire water system, the one north of the San Andreas Fault that we serve, about 3,000 homes along the Dillon Road, if you're familiar with that area, the Sky Valley, Indio Hills area. And it was an ideal system because it's about 15 miles long, and the wells are all located on the far northern side. And so it provides a long time to test the reaction and ensure that whether or not this would work in a water system. And it had good amounts of chromium-6 so that we could, if we could demonstrate it in this, it would meet all of the other wells that we have that might need treatment. So it's really simple. We add about 1/2 of 1 part per million of stannous chloride solution. You get an immediate reduction of chromium-6 to chromium-3. Remember, chromium-3 is that essential nutrient. And then we add about the same amount that we've always added of chlorine, about 1/2 part per million of chlorine. So this is a summary of the results that we found during the test. Remember, the rule had already been withdrawn, but we were still out there doing this work to demonstrate an alternative. And this is a 2-month test that the state approved us to do. And what we're seeing here are the wells on one side of the system, and then points along the system all the way to the light blue reservoir at the very far end of our system. So if we are complying at the reservoir at the end of our system, we knew we could comply using this process. So you can see when we turn the wells on, we immediately got a reduction. This red line represents the 10 part per billion level that we would need to be below in order to comply with that rule. And then you can see as time went on, we started to replace the water in the system with the treated water, and the levels reduced. And watching that light blue line, it took about a month to get that water distributed throughout the water system. And you can see we were able to demonstrate that we stayed below our goal level of 10 parts per billion until the time that we turned off the system. And then you can see the levels returned to that level that we see in our wells in our system between 16 and 20 parts per billion. So a successful test. The benefits, it's much more cost effective, and it doesn't produce any waste products. So the waste products, again, those hazardous materials that are developed, those have environmental concerns. There are none of those. There's no visual impact at these well sites. Often they're in those well sites that are in our neighborhoods. And that's very important. It also helps protect pipes. That's what it's an approved drinking water additive. You know, in areas that have lead problems, we don't have one here, but it would prevent lead from leaching in to the water. So that's an additional protection. And it didn't change taste, smell, or look of the water, so it was a real success. We have submitted our application to the state. They have it to allow us to implement this. We'll start in this same water system that we did the demonstration, and then move over to our large water system. Of course, all this is hinged on what the state comes out with as far as that drinking water standard. So I just wanted to give you that one example, and I'm certainly available to answer any questions you might have.
Thank you for that wonderful presentation, Steve. We do have one question right now from Julene. She says, you mentioned chromium regulations may double the cost of water. Could you please elaborate on this, please?
Yes. So when the rule was in place from 2014 to 2017, we did about $15 million worth of work developing a compliance project. And that's just the testing and research and design. The actual installing those facilities would have been in excess of $300 million. And the annual operating costs would be tremendous. So we know how much this is because we are already doing it at several wells down by the Salton Sea. So those costs would translate into about a 75% increase in drinking water rates. That's why we continue to look at an alternative, and that's where we landed on the stannous chloride option.
Thank you. We have another question in the Q&A right now. Matthew Grisby said, amazing presentation. Thank you. I'm curious if the chromium being found in the drinking water is the SR90 isotope.
No. So this is just think of, the typical chromium has a +3 charge. If you remove 3 electrons, when you oxidize chromium-3, you end up with chromium-6.
Great. Michael asks, he says, agree, so interesting and well explained. What other things are on the radar for things to watch for? Hearing a lot about microplastics as emerging and difficult to treat, and PFAS.
Yeah, microplastics. So we use 100% groundwater at our agency, and for all the agencies in the valley, we're almost 100%. Desert Water Agency uses a little bit of surface water, although I think that might be paused now. So the groundwater is highly filtered. So it's also quite old, the groundwater we use. So we don't think microplastics is going to be a problem for us. The testing is very tricky. It's amazing the amount of microplastics in our environment, in the air we're breathing, the clothes we wear, all of them, the thousands of fibers you're inhaling every minute. And just to try to collect a sample without contaminating it so that you actually know is very difficult. They're still working on that. So we'll watch it. We don't think it's going to be a problem for us, but it's definitely something that I'm sure they'll want us to do some testing for. The one thing we're watching, though, is PFAS. You're going to hear a lot about that. PFAS, per and polyfluoroalkyl substances. Basically, if it's non-stick, non-wrinkle, non-wetting, it's a PFAS. And we have it on our pans. We've got it on our clothes. that those materials that prevent stains, they're on our carpet, and now they're finding it in water. We've done testings. We haven't found it in our water here, but there are other areas of California they do find it, and across the country. And it is in our wastewater. When you wash your clothes, it's in the discharge from that washing machine. The first 6 washings of your clothes have the most PFAS in them. So, when you scrub your pan that has Teflon on it, that's PFAS, and it's going into the sewer. So it's mixing with water sources from just our everyday use. So we'll watch that one closely. And, there's thousands of these PFAS compounds, and 2 of them have been banned. So the testing alone is quite expensive and constantly evolving. And they are measured in parts per trillion. So again, one of those tests that it's very hard to even collect samples without contaminating the samples. Our samplers have to use special equipment. They can't put any personal hygiene products on their body. It's quite a process just to collect a sample and know that you haven't contaminated it yourself.
Great. Carol in the chat wanted to know if on the well sites that you showed, if there were any tribal wells that were in those on your map.
So on the map, those were all of the public water agency wells. And if the presentation is shared later, you'll see little blue water drops that represent those wells, which is about 140 or so wells, and pretty reasonably spread out. So it does not represent tribal wells. Those were the publicly available data that we use, but we have done lots of testing. In fact, we offer free testing at our state certified laboratory for chromium and arsenic. We do a lot of testing for both tribal and non-tribal wells, particularly in the eastern Coachella Valley, where that naturally occurring arsenic occurs. And so we do have a lot of data for those wells, and we see similar levels. That water doesn't change. It's been down there for thousands and thousands of years with these levels in it. So whether it's tribal or not tribal, you'll see the same levels.
Jim has asked about the cost increase to end users for Sky Valley purified water. So I think he's talking about the testing. Yeah.
So to be honest, the costs are not even in the ballpark compared to designing and installing huge treatment plants and the waste products that you got to deal with. So we didn't even do costs because it's almost insignificant. It's very similar to the chlorine that we add in costs. And so it would be less than inflationary from one year to the next, the cost to install. We installed those facilities for about $200,000 compared to, for that system, the cost to install conventional treatment ion exchange would have been close to $50 million. And so it's a very low cost. You're not going to see a rate impact as a result of that.
Great. And going back to the isotope question, I said chromium, but Matthew actually meant strontium, strontium. Can you answer it with that lens?
Okay, so we tested for total strontium. So it would be measuring both the radioactive isotope of strontium and the other isotopes of strontium. So we did not speciate the strontium. We just looked at total strontium.
Thank you. And
the reason why strontium is being looked at, because like fluoride, The concern is if the levels are too high, you might replace calcium with strontium in your bones, like with fluoride. That's why fluoride is regulated. And when that happens, your bones become weaker. So that's the concern. And the problem is that if you treat for strontium, you will automatically be removing calcium. So you got the pros and the cons. You got to weigh what are the health effects of lower calcium levels within the population. Calcium's in our water. It's one of the minerals dissolved in the water. One of the good things. Calcium is why water doesn't dissolve your pipes. That calcium forms layers inside the pipe that act as a natural anti-corrosion agent. It's primarily one of the reasons why we don't see any lead and copper in our tap water.
And I have at least two more questions here. One from Carol. She's asking about the cloudy water or the bubbles in our faucets and what's the cause of that?
Yeah, that's a real common one. And, it's air. So I like to equate it to when you open a soda pop can, that can is under pressure and there's dissolved carbon dioxide in it. And when you relieve the pressure, it comes out of solution. You see all those bubbles. That's the carbon dioxide. So water's similar. It's under pressure. It has dissolved oxygen in it. And the air can get into water down in the aquifer. We have an oxidized aquifer during the natural recharge that occurs, during artificial recharge. But during the pumping process, particularly, some pumping processes can put more dissolved air into the water than others. But either way, and it's variable. You may notice it more in winter, less in summer. It depends on the water use, the temperature of the water, all affects how much air is in the water. And I often just tell customers, take that glass, watch it, you'll see it clears up from the bottom to the top. That's the air coming to the surface. And just put it in a jug, put it in the refrigerator, and it'll be nice crystal clear when it gets cold.
And we have one more, and that's from Paula. She's asking, actually we have two more. Paula's asking though, how many wells from CVWD will benefit from the use of stannous chloride?
Yeah, so for CVWD, we have about 98 wells total in 2 water systems. We used to have 22 water systems when I started. That was a lot of reports I did. And we have over the years combined them and consolidated them. So now we have a water system on the north side of the fault and one water system on the south side of the fault. And so in total, between the 2 water systems, we have about 35 wells that would be anticipated to have levels above 10 parts per billion. So about a third of our wells would require some sort of treatment. And we have done already some bench scale testing for our large water system using that same process, mixing untreated wells with treated wells, and everything is working well. We've even done some tests for Coachella Water Authority and Indio Water Authority on some representative wells that they have and found similar results. It's working excellent across the board throughout the wells in the valley.
And we have one more question. We have time for one more question. Michael asked, we are recharging valley aquifers with surface waters, and he gives an example, canal water delivered from the Colorado River. Are we drawing the deeper groundwater layers, thus allowing the surface quality water to filter through the aquifer?
So yes, there is definitely mixing. And in fact, on that map I had, you saw different shades. And if you looked at where the nice blue shades were, that's where our recharge is occurring. Colorado River water has almost no chromium. So, and we actually saw when we started recharging down in the East Valley, We started a new facility for groundwater replenishment over near Lake Kauai in 2009. And it was in an area that had a good amount of chromium, in the 20 part per billion range. And gradually, as time went on, we're seeing the levels drop. And now the wells closest to that facility are below detection for chromium. And as time goes on, we're seeing that spread out. So yes, the surface water, now it also has a little more salts in it. Colorado River water, it still meets all drinking water standards, but it has more salts than some of the water we have in the valley. Parts of the valley have even more salt than what's in Colorado River water. So yeah, you're seeing the benefits of that recharge, and there's a mixing that occurs, and you do see that filtering through the aquifer.
Well, thank you. I know I speak for everyone when I say wonderful presentation, and thank you so much for that. And now, it is time, so we're going to go ahead and move on to our next presenter. And I have the pleasure of introducing to you Olivia Bennett, who is the non-potable water operations manager for the Coachella Valley Water District. She's been with the agency for almost 21 years, where she works with customers to encourage connection and use of non-potable water sources for golf courses and landscape and agricultural irrigation. She also supervises and manages the non-potable water crew and the control operators who are responsible for the non-potable water program, cross-connection prevention program, operation and maintenance of the non-potable water distribution system and the Mid-Valley Pipeline, operation of the Coachella Canal, and operation of the Palm Desert Groundwater Recharge Facility and the Control Center, which monitors all districts' alarms and facilities 24/7. Olivia, can I invite you to share your screen? If I stop?
Oh, yeah. All right, can you see it now?
Looks great, thank you.
Good afternoon, everyone. My name is Olivia Bennett, and as they mentioned, I'm the non-potable water operations manager for CVWD. I mostly work with golf courses, and so I direct this presentation for non-potable water and golf in the Coachella Valley. Does anybody know what the first golf course in the valley was? It was actually the O'Donnell in 1926. So we've had golf courses in the valley for almost 100 years. Second one was Indian Palms in 1947, and the third is Thunderbird in 1951, all the way to now we have 120 golf courses in our valley. This map is an overview of CVWD's service area. In CVWD's service area, we only have 105 golf courses, and it's color coded where the golf courses are depending on the source of water that they have available to them for irrigation. In the East Valley, or over on the right side of the map, all of those golf courses are highlighted in green, which means that they have access to canal water for irrigation of the golf course. The golf courses in the middle of the valley have access to recycled water and a blend of recycled water and canal water. The ones that are orange or yellowy orange are those next in line to be connected to non-potable water. If you happen to drive down Hobley Lane in the past year or so, you would have noticed that it was under construction for a pipeline expansion so that we could reach 4 more golf courses. And in the next couple of years, we will be inconveniencing you on Frank Sinatra so that we can connect another, actually that whole program is going to connect nine more customers. So it's going to connect golf courses on Frank Sinatra. And then we're also going to go north of the I-10 to connect a couple of golf courses there, as well as down Warner Trail to connect the tennis gardens and Southwest Community Church and a couple other customers there. On the map, we're moving towards the west. So we're heading towards Rancho Mirage as we make connections to non-potable water for golf courses. So those beyond our 5-year CIP, our capital improvement plan, are pink, but they are next in line. There are blue golf courses on this map, and those are ones that we won't be able to connect. They'll remain on groundwater as their water source. And it's just because our pumping plants and our pipelines don't have the capacity to reach them until we expand. But at this time, they're not a part of our non-potable water master plan. Again, as I mentioned, we have 105 golf courses in CVWD's boundaries. This slide just breaks down the number of golf courses per type of water use. Down here at the bottom, I just wanted to draw your attention. The bottom right, I put a red circle around it. 105 golf courses, and over half of them are already on a non-potable water source for golf course or land and landscape irrigation. So I know that you know this, and any other time of the year, I would say we don't get much storm water, but had sprinkles today, but typically we have 3 to 4 inches of rain here in the desert, so that we can't rely on stormwater for irrigation, not only on golf courses, but even in our own yards. And as we know, the other water source could be groundwater. A well owner would pump groundwater from the ground and apply it to their golf course or their property. The third source would be non-potable water. The icon over on the right, that's demonstrating what happens if it rains. You know, the water falls from the sky onto the golf course, and they don't need to use their well for several days. And at our homes, we don't need to use water on our lawns for several days after it rains. But you'll notice those pumps are still blue, and that's because we do still provide domestic water for indoor uses. So how much water, I always get asked how much water does a golf course actually use? And it really depends on where they're located and the type of golf course that it is. This is an evapotranspiration map. It's on our website, cvwd.org. And you can see that there's 5 different zones in the valley. And if you're a golf course and you're in zone number 1 or 2, you might only use 300 to 500 acre feet a year for irrigation. But if you're out in the wind belts, like zones 5 or 4, then you're going to use quite a bit more, maybe 14,000 or 1,400 acre feet per year. So the average last year for all of our golf courses was 998 acre feet. That was the average for the 105 in our service area. And so to make math easy, we're going to say that's an even 1,000 acre feet a year for a golf course. And because there's 120 golf courses in the valley, that means potentially 120,000 acre feet of well water could be pumped from the ground, but with the non-potable program, that doesn't happen. What's the big deal? Well, the whole point of this is to preserve our groundwater, because in the past we've been in an overdraft situation. And what that means is that we're pumping out more water than what's being replaced. And we work with the USGS. We've been working with them since '96. This graphic on the right here is showing uplift. Oh, sorry, I'm gonna hang up my phone. Shows uplift and subsidence. And where it's red, that's areas of up to 1.4 feet of subsidence. And what is there? What is in those red spots? You might be tempted to say golf courses because we're talking about golf courses, but really that's where most of us live. That's where our businesses are, that's where we work, that's where resorts are, restaurants, shopping, everything is mostly in those areas. So we do a big hit on those areas, and the district's been replenishing the groundwater since the late 60s. And I don't remember if you guys have already talked about that, but so when we replenish you have talked about it, okay. when we replenish the aquifer, we bring imported water in and put it into a pond and it percolates down. That makes the water available for pump well owners. So whether it's a golf course or even the district ourselves, that's what makes the water available to us. On the other hand, what we have, what's an opportunity for us is to do in lieu recharge. And so we have 38 golf courses that are in line for in lieu recharge. And that's when we substitute the groundwater use with the non-potable water use. And so this icon is showing when we pull water off of the canal and pump it to a golf course, or we may collect water from homes, wastewater from homes, and treat it and clean it and disinfect it, and then provide it to a golf course for irrigation. And you'll notice those golf course owners' wells are off, they're grayed out, and that's the goal. It's the goal of our water management plan, one of the goals of our water management plan. That's so that the water management plan was developed to prove that we're going to be able to meet our current and future demands and have sustainable water sources. As it pertains to non-potable water, we said in the water management plan that we're going to fully use available Colorado River water supplies, continue developing recycled water as a reliable local water supply, and implement source substitution programs. So that's basically where instead of groundwater, we're going to provide a non-potable water. And then of course, water use efficiency across all sectors is important. Strictly pertaining to golf courses, they're to focus on conservation and utilizing non-potable water for their irrigation source in that plan. And the golf courses were aware of this and they wanted to participate. And in fact, in 2013, they approached CVWD and wanted to develop a task force, the Golf and Water Task Force. And we developed a mission statement. We worked with them to develop a mission statement. And in that mission statement, they addressed that they want to institute some conservation measures and to expedite the use of non-potable water. So they are on board with the non-potable water program. They are aware of the water management plan and they do want to participate in it. I've said non-potable water several times, but now I'm going to tell you exactly what I'm talking about when I say that. The first type is canal water or Colorado River water, and a golf course would have access to canal water via the Mid-Valley pipeline or directly off of the Coachella branch of the All-American Canal or from the canal water distribution system. And the second type is recycled water. And we provide disinfected tertiary recycled water from our treatment plants to golf courses and for landscape, golf course and landscape irrigation. And it's important to know that, you know, there's potable water sources and non-potable water sources, and we want to use potable water sources for potable reasons and non-potable water for non-potable reasons. That way, the primary source of water isn't groundwater and it can be non-potable water. So how are we doing? In the East Valley, for our canal water connections last year in 2022, about 21,000 acre feet of water was used for golf course irrigation, which was 74% of their total irrigation demand. And so our goal to have all 33 golf courses in the East Valley connected would be 33,000 acre feet a year or so. We've got 3 more golf courses to connect out there, and we've got a little bit of improvement to do. However, in the Mid-Valley area for non-potable connections, remember those purple courses from that aerial map, last year it was over 24,000 acre feet, which was 93% of their total irrigation demand. And our goal, because there's so many more golf courses to connect in the Mid-Valley, would be up to 61,000 acre feet per year. So our goal and what we require for a non-potable water golf course to meet is 80% of their total annual or fiscal year's irrigation demand with non-potable water. So if you add those two numbers or percentages together, it's about 83 or 84%. So across the board, they're meeting the goals. For canal water, I think you've probably covered this, but just wanted to give you an idea where that actually comes from. This is an aerial of Southern California. Over on the left would be the ocean, and on the right would be Arizona. Between us and Arizona is the Colorado River, and that's that blue squiggly line going all the way down to the bottom. Off of the Colorado River at the bottom is the All-American Canal in blue going left to right. And shooting straight up off of that is the Coachella Canal. It's the Coachella branch of the All-American Canal. And it's 123 miles long. And as you see, it kind of fish hooks there towards the end, and it terminates at Lake Cahuilla. Well, within that fish hooked area, we have 1,300 customers, and 30 of them are golf courses. I just like this picture, so I always include it in my slideshows. I think it's out at Silver Rock, and I'm just telling you that we still have some golf courses to connect out in the East Valley, but we hope to have that done by 2025. We've been connecting golf courses in the East Valley since the late 80s. The first one was PGA West, I believe it was the stadium course, and we've been connecting golf courses ever since out there. You can see the use of Colorado River water for golf courses has increased over the years. And the next water type is recycled water. CVWD has been in the recycled water business since 1968. When we took over the domestic water system serving Palm Desert Country Club, they had a package plant there that was treating wastewater to secondary effluent, and they were using that to irrigate the golf course there. So when we inherited the domestic water system, we inherited the wastewater treatment plant, and then CVWD was in the sanitation business. And today we have 2 wastewater treatment plants that provide disinfected tertiary recycled water to golf courses and for landscape irrigation as well. What is recycled water? It's municipal wastewater that's collected from homes and businesses and receives a high level of treatment at a water reclamation plant. And we monitor those plants 24/7, and we collect water quality samples all day long. And in fact, every day, every week, every month, every quarter, every year, we're collecting different types of samples to be tested to ensure that our permit regulations are met and so that we can provide safe recycled water to our customers. So this is Robert, and he is a water reclamation plant operator. He's holding a beaker up with secondary effluent. So in the wastewater world, there's primary, secondary, and tertiary recycled water. Each are approved for specific uses, but again, CVWD provides disinfected tertiary recycled water. That's the different stages: first stage, second stage, and third stage. But this secondary effluent's pretty clean and it looks pretty good. So I'm going to show you in a slide now, and if you are eating, maybe you want to stop or look away. It's not as gross as you would expect, but it is what it is, in that the first cone is influent. This is water that comes into the treatment plant, and you can see it's cloudy and there's some organics in it. The second cone is secondary effluent. That's what was in the beaker that Robert was showing. It's cleaned up pretty good, because when that influent goes into be treated, there's microorganisms that consume all of that turbidity, all of those organics, and they clean up the water pretty good. You'll notice that it's a little bit turbid still, and there's a tinge of yellow or tan still going through it if you look at the very top of the water. The next cone, that's tertiary water. It's been filtered and disinfected, and it is very clean. It's see-through. You can't see any tinge of yellow. In fact, it's so similar to potable water, our domestic water, that we have to provide our recycled water in purple pipes. That's to distinguish it from the domestic water so that we don't have any cross connections. And to ensure that when recycled water is provided, it is safe, our customers have to go through a rigorous training. We just had our training event yesterday. It's 4 hours long, and we tell them all about the do's and don'ts and the rules and regulations for the use of recycled water. Our customers have to have a permit with CVWD and an agreement, a non-potable water agreement with CVWD in order to use the water. They have to make everything above ground purple as it is related to the irrigation system, and they have to put up signs. They have to send out a notification to the public that they're going to be using recycled water. And to prove that it's not connected to the domestic water system, we conduct cross-connection shutdown tests every 4 years. That's to make sure that, there isn't going to be any connection between the two water sources, and so that it's not safe. And we always go back every quarter. We're required to do quarterly surveys to make sure there's been no changes on the irrigation system. And then that kind of monitoring and other monitoring, and we are required to report to the state what our findings are. It's highly regulated water source, as Steve mentioned. In the state of California, there are 43 allowed uses of recycled water that are approved. And I'm going to show you something here in a minute. And I don't know if you have a printout of it or not, but we can get you one. There's a lot of uses listed on the left-hand side, and then the different levels of recycled water treatment. And remember, CVWD provides disinfected tertiary recycled water, and it's approved for pretty much every use that's listed there. And anything that's approved or allowed is green. So you'll see playgrounds, schoolyards, residential, freeway landscaping, cemeteries, ornamental fountains, snow blowing, and of course, there's a lot of agricultural use there. All of those are approved for use for recycled water. A couple of years ago, they did a survey of the state. They always update this survey, and they found that for the most part, looks like the majority of recycled water is being used for in-stream flows. And that's where we put water in the streams to make sure that they can be used for recreation or for plant and animals, ecologically, their homes, make sure they're safe for spawning or migrations and things like that. The second highest use is golf course and landscape irrigation. And the third is agriculture. But at CVWD, we provide recycled water for golf courses, HOAs, high school athletic fields. Even our buildings here at CVWD, the landscape around them is recycled water. And in the near future, we do intend to provide recycled water for agriculture. 10 reasons why we provide recycled water here in the Coachella Valley is because the Department of Water Resources projects a large statewide shortage, and groundwater is our drinking water source. We want to protect that. And if the state comes in and doesn't believe that we're following our plan, they could adjudicate our groundwater system and put high regulations on what's allowed to be pulled out and what's not allowed to be pulled out. But as we mentioned before, in our water management plan, we did say that we're going to provide recycled water because it's a reliable local water supply for irrigation. And if we irrigate with recycled water, it saves groundwater. We want to prevent future overdraft of our groundwater. So that's what the in lieu recharge program is about. And again, to use potable water sources for potable purposes and non-potable water sources for non-potable purposes. As you saw, there was 43 approved uses, and pretty much any non-potable water use can be used with that tertiary recycled water. It's more economical than advanced. There are areas in California that are treating recycled water to potable water sources, but if we were to convert our treatment plant to that, that would cost millions and millions and millions of dollars, so much more than what we are paying now to connect the golf courses, which are large end users, and they do use a lot of recycled water. And of course, it's more economical than buying additional imported water rights because those rates are very high right now. Problem with recycled water is that we run out. In the winter, there's a lot of snowbirds in the valley and they're flushing their toilets. And in the winter, a golf course's irrigation demand goes down. And then the vice versa, in the summer, the irrigation demand is high, but there's not a lot of people here in the summer. So what we did was build the Mid-Valley Pipeline, and that supplements our recycled water supply with canal water. The Mid-Valley Pipeline is a 54-inch pipeline that's in the stormwater channel and brings canal water from Indio through La Quinta, through Indian Wells to Palm Desert. It's about 6.7 miles long, and it supplements our recycled water supply. Last year, it provided about 13,000 acre feet of canal water for golf courses in the Mid-Valley area, and we have a Palm Desert groundwater replenishment facility here in Palm Desert as well, and about 11,000 acre feet were replenished with the Mid-Valley Pipeline water. So remember at the beginning, I showed you the map, and the tail end of the Coachella Canal was that fish hook. This is a zoomed in picture of that fish hook, and the canal is 123 miles long. At milepost 115.5 is where the Mid-Valley Pipeline connects, and that's that dark line on the map there. It's connected over by heritage palms, and then it goes into the canal or the stormwater channel for 6.7 miles, travels up to Palm Desert to our water reclamation plant number 10 that's on Cook Street. This is a schematic that I like as well. It kind of gives you a better visual of what's happening in that we have a pump station that pulls canal water off of the Coachella branch of the All-American Canal. It's pumping into a pipeline in the stormwater channel up to our water reclamation plant number 10 to a storage reservoir. Meanwhile, we're collecting the sanitation or wastewater from homes and businesses, taking it to our water reclamation plant, treating it, cleaning it, disinfecting it, and putting it in a reservoir where we could blend with canal water and then send that out to our golf courses or our customers. We've been doing recycled water in the valley. Remember I mentioned first one was Palm Desert Country Club since 1968, and we're connecting golf courses ever since then. You can see the water use has gone up. And this is just a picture of construction going on. As I mentioned, all the pipes have to be purple, but some pipe material doesn't come in purple, so they have to put it in sleeves of purple plastic before they put it in the ground so that there's no potential cross connection. The bottom two pictures are again of the Mid-Valley Pipeline when it was put into place in 2009. This map shows the non-potable water master plan implementation schedule. Here, if you look at I guess it's dark orange with kind of a brown outline, those are the 4 golf courses that are going to be connected later this year. That was the work that was being done in Hoveley Lane. All of the work on the golf course itself and in Hoveley Lane is going to be done soon. We are in the process of constructing a whole nother pumping station so that we can serve them, as well as if you look at the orange and lighter brown outline, those are the ones that we're going to be focusing on next. As I mentioned, we're going to go down Frank Sinatra, and those golf courses you might not be able to see. It might be a little blurry, but it's Annenberg and Tamarisk and Rancho Mirage Country Club and Suncrest. We're going to go across the 10. We've already got Classic Club connected. That's what's highlighted in green across, north of the I-10. But we're going to reach the Tri-Palms and Jack Ivy Ranch, as well as coming down Warner Trail. Direct your attention back over to the right lower. That's where the Indian Wells Tennis Garden and the Southwest Community Church and Palm Royale are. After that, we'll just continue to expand a little bit further the next color is the yellow, and then the red. I don't know why they use colors that are so similar and hard to describe. Stick to the primaries. That's what I usually use. So when we're all said and done, remember the total number of golf courses was 105 in our service area, and we hope to connect about 95, which would be 90% of the golf courses in our service area. So here's where the math comes into play that I mentioned earlier. If a golf course is using 1,000 acre feet of water per year, and we have 120 golf courses, that's 120,000 acre feet of year that they could be pulling from our groundwater. However, because we have 30 golf courses in the East Valley and soon to be 3 more, and all of the golf courses in the Mid Valley to be connected. And by the way, Desert Water Agency in their service area, they serve 6 golf courses with recycled water. So if we're subtracting from 120,000, get all of these golf courses on non-potable water, we could get down to 19,000 acre feet per year, which is quite a reduction of the impact to the groundwater. And that's all I have. Thank you for listening.
Wow, that was some good information. We've definitely got some questions for you. And the first one is from Carlos. And he's asking about the non-potable water. If it was not used for golf courses, where would it be re-injected into the aquifer?
Well, we're not injecting into the aquifer, but we do have, let's see, should I close out of this and will I be fine?
Sure.
Okay.
I think he's saying if it was not used for golf courses, where would we possibly?
So right now, even there are some like Indio Water Authority and Coachella, and we have a water reclamation plant, and we discharge into the stormwater channel, and it flows all the way down to the Salton Sea. So that would be the in-stream flow use.
Great. And then we have a question from Councilman Steve Sanchez, who's asking about when we talk about pumping more water out of the aquifer and replenishment. He wants to know if this is measured annually, and if it's bad, do we look at it? Do we ever balance it out by the years, or do we over replenish some years more, some years less, other years to kind of balance it out? And is this a good or bad thing?
Yeah, I think I would defer to Steve because they handle the groundwater replenishment monitoring and reporting.
Yes. Can you hear me?
Yes.
Yes.
Okay. We do have wet and dry years, and in fact, the whole program of how we receive our state water project water, which, by the way, between Desert Water Agency and CVWD, we are the 3rd largest purveyor of state water project, and there's no pipeline to get it to us. So we trade that water with Metropolitan, and the benefit of that is during wet years, they can deliver advanced deliveries, and then in dry years, we may get no water for several years, but we have that advanced delivery that's already in the basin. So it's really a great program that basically acts as a great storage reservoir for water that would otherwise be lost and not used beneficially.
Great, thank you, Steve. Another question from Jim. He's asked about the capacity limit for recycled water for courses. Can you treat everything the courses would want?
Our wastewater reclamation plant number 10 has the capacity of 18 million gallons per day. However, for tertiary treatment, it's 15 million gallons per day. And right now, I think our highest actually that we bring in is maybe 10 million gallons per day. So we're not at our capacity yet at the treatment plants. And as I mentioned, in the summer, we do run out of recycled water. So we wouldn't meet it all with recycled water. That's why we supplement with the Mid-Valley pipeline and the canal water.
Perfect, thank you. Jean asked, can HOAs without golf courses use recycled water, and is it less expensive than what we might be currently using? And how can an HOA determine what type of water they are using for irrigation?
So if an HOA does not own a well, they're more than likely irrigating with domestic water. We already have 4 or 5 HOAs that are not associated with a golf course that are connected to non-potable water. Non-potable water in the Mid-Valley, we use a type A rate, which is tied back to the replenishment assessment charge. Non-potable water in the West Valley, the type A rate is $186.95. And your domestic water is probably around, if you're efficient, $500 an acre foot when you do the conversion. And if you're inefficient, it could be upwards of close to $2,000 an acre foot. So you would have to do a cost analysis to determine if it would be feasible to make the connection to non-potable water. It is the cost burden of the domestic water customer to pay for their connection to non-potable water.
And Julene was asking about the same question about the cost of tertiary versus domestic water, but she also is asking, how does an HOA get to use recycled water for landscaping? Can it be requested and that the costs be change over, and who would cover that?
Yeah, it's the cost of the domestic water customer to make the connection to non-potable water. Connections are well, for the meter and the vault and the clay valve and everything, telemetry for monitoring, it's about $300,000 just for that. And if we have to do any sort of pipeline expansion, then that would also be the burden of the domestic water payer. So that's what I mean. You have to do a cost analysis to see if it's feasible or not. I ran a cost analysis for a few customers about a month ago. They were near Tamarisk, who were going to be connecting in the next couple of years. And the payback period was about 99 years. So for them, it wasn't feasible.
I'm not sure if you can speak for DWA, but there was a question about DWA's treatment plant and an HOA that's across the street, and they want to know if their HOA could tap into recycled water there. Do you know anything about their capacity?
No, and I don't know where their pipelines are located, so.
We'll try to get that, Sam.
I can chime in if that's okay. I'm with
Great.
Desert Water Agency. My name is Ernie. Currently, no, even if they are situated right across the left line, there currently isn't anything. If it's been down the line, I'll update you. But so far, it's just for the golf courses that we have hooked up so far.
Thank you, Ernie.
You know, CVWD has to do a cost benefit analysis too, and the large end users are golf courses. They use more water than an HOA typically.
Sam also asked, why is canal water considered non-potable? Can it be treated to potable uses?
It can be, but as a raw water source, it's not potable.
And then we've got a piggyback question off Julene's question about the HOAs. Is that water okay for your pets or your animals or communities with fruit trees, humans, kids who play on the grass, etc.?
Yes, there's 43 approved uses for recycled water, and full body submersion is one of them. There is a park down in San Diego called Sanity Lakes, and they boat and they swim and they fish in the reservoirs that are filled with recycled water. It certainly is approved, and just as a dog might play in a puddle and might drink in the puddle, I mean, it does get treated with chlorine. So if you were to drink chlorine from a pool, you might have an upset stomach as well.
Great. That is the last Q&A. If anyone has any other questions, please type them in. We have a couple more minutes. I do have Cy Nelson wanted to say that, thank you for the information and appreciate all of your efforts to safeguard our water supply. So I wanted to make sure you got that comment back. Any other questions? We're open right now. We've got another 7 minutes if anybody has anything. Sam did ask for some clarity. Canal water is not recycled, correct?
Yes, it is not the same water. Canal water comes from the Colorado River, and recycled water is water from homes and businesses that's wastewater goes down the drain or flushed in toilets. It's been treated and is tested and proved safe.
Great. Well, I think that is all the questions we've had and all the chat. Oh, wait, I spoke too soon. Someone's got a question for Steve, if you're still on the line. They wanted to know about what vitamin C does.
Oh, so remember when they came out with that chromium-6 standard and they didn't give us any time to comply? We wanted to make sure we had a method to comply, which would be a alternative variance. Because it takes time to build these facilities, 5 years minimum to design and treat and build. So, and you know, if you don't comply with drinking water standards, you can be sued, and it can be a really big deal. So we, in our lab, I did some research, and vitamin C is a great antioxidant. And so you fill up a gallon of water, and you can buy some powdered vitamin C. Ascorbic acid is vitamin C, and it's a reductant. And when you mix in about 200 milligrams, if you can find a scoop small enough, that was a challenge alone. But it's about 1/5 the size of a 1,000 milligram daily tablet. And you shake it up in a gallon of water and let it sit for about 5 minutes. And you now have water that has chromium-6 levels that are almost non-detectable. And we were going to roll that out if we were in a position of not being able to comply with that rule to avoid any litigation risk. So ultimately, we got SB 385, which gave us 5 additional years to comply. It was really shocking that the rule came out without any time to comply. It's just to think that we had to get legislation to provide us an opportunity to do the right thing and install treatment to comply with the new regulation. But that's why we developed it. I called it Plan C. And we were ready to roll that out if that legislation, we literally got the legislation 2 weeks before we would have been collecting the next round of quarterly samples that would have determined we were out of compliance. And it was adopted as an urgency measure by 2/3 majority of the legislation. We actually got about 80% of the legislators to support it.
Thank you, Steve. Olivia, I've got a couple more questions for you. One is asking about requirements for reclaimed water. Do we have any requirements, for example, for the Salton Sea?
For discharge?
For returning reclaimed water back. And the example I gave was the Salton Sea.
Yes, any water reclamation plant will have a permit to determine what their limits are for water quality with whatever end use they have. And they're very stringent if you're going to discharge to a water body of the state. So yes, there are extreme regulations on what water is being discharged. I don't know, Steve, if you wanted to add anything to that, but it's an NPDES permit if you're going to discharge to a body of water.
Yeah, that's correct. And we have a petition to the state. You have to get plans to stop It's funny, you know, the National Pollutant Discharge Elimination System, that NPDES, is to eliminate wastewater discharges. And that's what we want to do. We want to stop discharging it and recycle the water. But we got to go through a petition and get approval from the state. We've been working on that for about 3 years, and we have more work to do, but we hope we'll be successful because the state generally supports recycled water, and we expect to get their support and be able to implement a recycled water program in the East Valley, and Olivia will be even busier.
Great. I'm going to double up on two questions here. What percentage of CVWD wastewater is recycled? And do we ever produce too much water during the recycled water during the winter? And if so, what do we do with it?
Yeah, so about, I think it's 60 to 70% of wastewater is recycled. And then we have evaporation ponds and a lot of reservoirs down at the reclamation plants where we store recycled water for future uses, should we need to, if we have too much that doesn't go out to the golf courses. But the whole purpose of these connections is to find a home for every single drop of recycled water that comes into the plant. And if we have to supplement more in the summer with canal water, then that's our plan. But the purpose of these non-potable water pipeline expansion is to find a home for every single drop of recycled water. And then if it rains like it is this week, that's when we would use our storage reservoirs.
And very last question, new golf courses and other developments, are they required to use non-potable water for irrigation and fountains, etc.?
You're required to connect to non-potable water if we bring it to you. And so we're bringing it to you.
Very good. And we have one last one from Michael. We can do it offline. We are out of time. It's 1:30 and I want to make sure I get you guys out of here on time. Thank you again so much. We will be sending out a survey. Chris will be sending that out. And then we will also see you all next week. Thank you to our presenters. Wonderful job. Thank you.